Welcome to ICS Arabia. Shakespeare once said, to be or not to be. He asked this question about human issues and existential philosophical issues. But I know somebody who was contemplating on some OT issues that many in the OT community find challenging. And once he said, to scan or not to scan, that is the question by Raphael Arakelian. Arakelian, right?
Yes, that's correct.
So, uh, welcome.
Thanks,
So,
Dr. Sulaiman.
yeah, welcome. So, tell us about yourself. Could you introduce yourself, please?
Sure. So first off, thanks for having me, Dr. Sulaiman.
You're
I'm
welcome.
Raphael Arakelian. You got the last name correct.
Yeah.
I am a OT cybersecurity manager. I currently work with Accenture, but in my career, I've primarily focused on OT cyber monitoring, or as others may call it, OT visibility. I have a passion for understanding the technology and developing services around it, whether it's head-to-head evaluations, implementations, assessments, and so on. So, as you mentioned, this is a topic, the scanning topic is a big one that comes with OT cyber monitoring or OT visibility, and many asset owners ask about this question. So, it is something that out of curiosity and to help asset owners understand this topic, it is a research that I decided to embark over a year ago outside of my typical day-to-day job. And the findings in the study is what I presented as for. And today we will have a conversation, you and me, about that study and some of the findings.
Interesting. So this idea came to you by observing what's going on in the community and the debate about scanning, whether to scan or not. Okay.
Yeah.
So could you tell us please about this project and share us something about it?
Sure. I can
Yeah,
walk you through the presentation itself, and then at certain times we
please
can
go
take
ahead.
a look at specific details. So, as I mentioned, the basis of this study began because when I started my career understanding this technology, especially the active part, it was a question that I used to ask, well, all the vendors, what is the risk of active scanning on devices? And I felt even today, there is no real quantitative risk. Some vendors would say, oh, there is no risk. Some would say if you run the scan out of 10 times, maybe one or two, you will have an issue. Maybe something will affect the controller and so on. But it was never an actual answer where you say, for this controller or for this device, if you do this scan, and if it's the correct scan or the inappropriate scan, here is the exact impact. So that is the basis of the project, to come up with a quantifiable method that can determine what will the impact be on a PLC when you scan it. The timeline that I'm showing here, and I talked about it at S4, really it's been a journey for these products, and it's been a bit of a roller coaster because in the beginning it began as passive detection, as we know, and then Indigi had patented this ability to do active scanning on OT devices, although there were, for example, other companies or other individuals who may have been using that concept in OT environments. But Indigi was the first who actually took that to the market. But I believe the market was not ready yet for that concept.
Mm.
And over time, as the value of this active scanning for OT environments showed up, more and more companies more vendors for OT visibility or whatever you want to call it, OT monitoring products, they started to adopt this. So now, from 2018 till today, we see a wide adoption of the scanning. But the question that I had and the question that you posed in the beginning of this presentation is still a question that is not answered.
Mhm.
And this here I emphasize is an important thing, even though we're saying active scanning. In my study, I differentiated between two types of scanning.
Mhm.
So there's the traditional active scanning, which we know there's vulnerability scanners, for
Yeah.
example, or attack surface management tools that do that. They basically scan all the ports and services of a device. Or maybe it is more targeted and customized, but it's not really developed for OT protocols for a specific interaction or query. And then there's targeted active scanning, as I uh, chose to call it, which is designed for interactions with OT endpoints, whether it's controllers, whether it's VFDs, etc. So it's very specific. It is specific to the protocol. It is also it's also a type of scanning that can extract information of the response from the PLC or the OT endpoint to enrich the information that could not be obtained by passive detection alone. And the reason I chose to come up with this uniform term of targeted active scanning is because at the end of the day, what we see in the market is that each vendor comes up with its own name. Someone says
Mhm.
it's active query, someone says it's smart polling, and then the asset owner is a bit confused because when marketing language comes in, they say,
Mhm.
"Oh no, like I do smart polling, so it's like a little bit better than active query or whatever it is." But fundamentally, the technology or how that scanning is developed is fundamentally the same. So it should be named as a unit in a uniform way. So this is the basis of my study. Did you have any questions, Dr. Sulaiman, based on these couple of
Yeah.
slides?
So what do you mean by targeted is to specification for each PLC, right?
So it can be, yeah, based on each PLC.
Customization, like, yeah.
Yeah. So the idea is you have some basis of information before
Hmm.
when you've done passive detection, where for example, X, Y, and Z are Rockwell devices. Maybe those other devices are Siemens devices. So then instead of doing this traditional active scanning approach to investigate um, all the ports, let's say, or using a more generic type of protocol for the scanning, you can then use a targeted scan to those Rockwell devices. You can
Mm.
go further on if you know that it may be a PLC, then you can, I don't know, you can use a targeted active scan that mimics or replicates the Ethernet IP
Oh.
communication. Or with the S7 PLCs, you can simulate something related to the S7 COM protocol or the S7 COM plus protocol. And by doing so, you are essentially limiting the amount of unnecessary traffic
Mm.
that that device will receive and will affect its day-to-day operations or day-to-day processes. That's the whole idea of doing a
Mm.
targeted active scan that these OT monitoring products support.
So do you advise vendors to adopt this idea and test their uh, products for targeted active scanning and then to distribute this to the community and asset owners, right?
Yes, so that is actually
Mm.
the basis, right, in terms of the gaps that I wanted this study to address. I had many questions in mind. One of them was like, is there a systematic methodology that can be done by vendors and also by asset owners before they adopt using this technology? I
Yes.
wanted to understand, can different monitoring products behave in a similar way, or will
Mm.
we expect differences in terms of the impact on the PLCs? But also the other question I wanted to investigate, target active scanning, the idea of it is not something that was invented out of like vacuum. It basically is really just replicating the querying that happens between diagnostic tools, or whatever it's called. It can be referred to maybe the engineering workstation software,
Mm.
but that interaction is what is being replicated. And so when vendors of these products position their technology, they say the impact is going to be minimal or no impact because this is what it's replicating. So this is something else that I wanted to investigate. Is this actually true in terms of the numbers? If I get a diagnostic tool and I do a query based on the native protocol of the OT endpoint of the PLC, will the impact be the same if I were to use a OT monitoring product that is trying to replicate this mechanism or this interaction? And this is something that we will discuss later.
Sure.
And then, of course, the other gap was to look at traditional active scanning.
Mm.
So the broad scanning, what would that look like in terms of impact on the PLC?
I've been wondering for a long time why the scanning only addressed to PLCs. Why not addressed to other ICS devices like HMI, uh, SCADA, whatever?
I know. I think that's a valid question and valid scope. I would love to take this approach and have it more broadly. I think HMIs, if we're talking about just workstation HMIs, perhaps it's not really
Mm.
that much value in terms of doing it. But if it's, panel HMIs, for
Panel
example, then yeah, there could be value in
or
trying to
RTUs. Yeah.
assess. Yes, RTUs as well.
Mm.
There
Okay.
there's value in evaluating that as well as part of this methodology.
Okay. So
Yeah.
please go ahead.
Sure. So in terms of the setup, basically what I did is I created a small network, and you'll see on the right, I used three types of PLCs. I was limited in terms of what
Oh.
I had, and that's an important disclaimer, right? The study was more about um, coming up with a methodology or validating a methodology rather than trying to find out the answer for all PLCs or all situations, because that is very, very difficult to do. So the three PLCs in Allen-Bradey Compact Logix 5370, I also had a Phoenix Contact PLC Next. Specifically, it's the AXC F2152 and the Siemens S7 1200.
Are these
So
yours or for somebody?
I had to, let's say, borrow
Ah,
borrow them to do that.
okay.
Um, so that's on the right side. On the left side, I basically had two important laptops, or let's say workstations. So the first one I refer to or labeled as a cyber laptop. So this one had basically all the tools, all the candidate tools that were going to be investigated in the study. And from this laptop, all the active scanning
Mm.
was getting conducted, and only one tool would scan at a time. Not all three of them would be scanning or operational. The second laptop was more, I call it as a control. So basically, to explain what happens,
Mhm.
um, I had Wireshark open on the cyber laptop. So when I would start a scan, I would also run Wireshark to see what
Mhm.
traffic
Yeah.
is exiting and coming in. So even though I would have the timestamp of when the packet exited the cyber laptop, it's not that easy to then go back to the PLC
Mm.
and see when exactly the scan started.
Mm.
Because even though I had an NTP source which meant all my devices were synchronized at the same time, there's always a bit of a, let's say, a discrepancy in terms of the timing. So basically, to avoid that, I created an offset experiment. What I mean by that is I would first scan the collection laptop, which also had Wireshark. So this way, when I start the scan on the cyber laptop and I open Wireshark, I will know exactly how long it took
All right.
for the packet to reach the collection laptop,
Okay.
because I can calculate the difference or the offset in the number between when I sent it and when the collection laptop received it. So I then did an assumption that the difference in the time between these two components will also be in the same magnitude in the difference of time between the cyber laptop and the PLC. So this way, I would know when I go back to the logs of the PLC and to see every individual parameter that's logged, I would know exactly at which point the scanning began and at which point the scanning ended. And I'll mention why this is important later, because there were certain parameters that I
Okay.
was logging on the PLCs and I had to investigate those.
Okay.
And then when I talk about logging of parameters, basically I used an edge gateway that was collecting that information from each individual PLC when the experiments were happening. But the challenge with that is, again, as I mentioned, you will get the timestamps, you will get the parameter, but this will happen at every scan cycle. So like every 10 milliseconds, so you have like thousands and thousands, you have like 18,000 data points and so on. But you have to know when scanning began. And this was a bit of a manual method. I think in the future iteration, I would like to have some automated or semi-automated method to know that when I started or clicked the scanning, that's exactly I can correlate back to when the what data point it is on for the PLC log.
So if we summarize, the cyber laptop is the scanning laptop, and the collection is the packet like Wireshark, right? And the edge is the database, right?
Yes.
To store the traffic, the whole traffic, right? Or
Not the traffic, but because my methodology um, focused on collecting or logging certain parameters on the
all right.
PLC, but I have to be able to get that data to then analyze it. So that's the point of the edge gateway, and I chose two parameters to investigate
So
for the
how do the edge gateway talk with the PLCs? How does it get the parameters that you're looking for, or it doesn't?
It's basically like
Yeah.
ignition. So like it's the equivalent of a SCADA application that is
All
polling
right.
the data at frequent intervals.
So it
So
gets its feedback from the collection, or
no, the feedback is from the PLC
from
directly.
PLC goes to the edge gateway.
Yes. Yes.
Is there like a special software to do this, or
Well, it's
it's
based
ignition?
on,
It's the ignition, right?
yeah, it's based on ignition itself.
So the ignition is a SCADA vendor. So the watchers can, I mean,
Yeah, they're not
can,
in the traditional sense. They're not the traditional SCADA vendor, but
hmm,
like they have that
okay,
capability.
I get it now. Yeah.
Yeah.
Okay.
So that's in terms of the setup. Next we can cover the PLC details. So as I was mentioning, right? Um, I
If I
was I
interrupt, did you choose this setup straight away, or did you experiment with different setups until
did I
you got the best one?
the setups.
Did you
mm,
like choose different setups before this, or you just chose this straight away?
Oh, I see. No, I had to come up with iterations in terms of
Hmm.
the design.
Oh, so you were
Uh,
experimenting with the design. Okay.
yes, but I didn't physically build those.
All
But
right.
eventually, it got to, like once it got the design got to a stage where I knew it would bring the insights that I need, I decided to execute on it.
Okay.
I also have to mention. There have been other researchers that have looked into this concept, and even my
Hmm.
methodology, especially the part about how I ran the experiments, I
Hmm.
adopted from a another paper that was published. It's from University of Osborne. They also focused on PLCs, but they did not investigate these OT
Hmm.
monitoring products or this, let's say, the targeted active scan.
Hmm.
They actually did try, let's say, Nmap, which is targeted, but it wasn't, it wasn't, let's say, the same tools and even the methodology itself. I
Hmm.
basically took the lessons learned from their findings and incorporated in mine. So that's why, for example, I did network traffic analysis, which
Okay.
is something that they didn't do. So therefore, even when they saw an impact on a PLC, they couldn't necessarily explain why it happened.
Okay.
So that's why this Wireshark part is very important.
So for my, I mean, viewers, Raf
Mhm.
is also a researcher. I mean, as well as he's an engineer. So
Yes, yes.
yes, yes.
Um, I don't know why the formatting is not looking good here
Right.
on the right, but anyway, um, you can just ignore that. So yeah, I was mentioning two parameters were important for me in the experiments in terms of logging on the PLCs. One was the scan time, and the other was memory utilization. And what happened is the three PLCs they had the exact same program. Uh, you know, the same program in them. And the reason why that's important is because whenever you're taking the research lens, you want to minimize the number of, let's say, the number of disturbances between devices. So
Mm.
if you have one PLC that has a massive program and the other has a smaller program, the impact, let's say, that may happen may not
Mm.
be the same. So you have to minimize the number of variables. And then the scan rate was set for all the PLCs at 10 milliseconds. And that's why I was saying there were a lot of locked parameters that had to be looked at. And this one I also mentioned, there was an NTP source in the
Mm. Mm.
environment to synchronize everything. And another important thing is when I was doing a scan on a PLC, I was making sure that there were no other interactions that were happening with the PLC. So, for example, I wasn't opening another computer that has a diagnostic tool to communicate with that PLC. No, it's only the scan to the PLC, the
Mm.
PLC responding to the scan, and the PLC sending its data to ignition
Mm.
to log the information, which is
Mm.
it's never going to be just one to one in the environment. There will be many devices interacting with the
Mm.
PLC, but again, I had to minimize the interactions of the PLC.
Did you have to read about each PLC specifications
Mhm.
in order to know how to interact with it, or you just experimented and then by trial and error?
No, I had to read through them.
Okay.
I also consulted on
All
people
right.
who work on these devices day in and day out.
All right.
And they provided me a lot of help. I
Nice.
have to say, like, without their guidance, it would have been The 1 year project would have taken me much longer, especially
Yeah.
since I'm doing this outside of my regular 9 to 5 job.
Okay.
Yeah, so here in terms of the methodology, this is also experimental design or thinking, and this is very important.
Mm,
When someone is testing a medication or a pill, there's always a control, right? Like,
mm,
for example, for one day you don't take the medication, they check your blood sugar levels. The next day
mm,
you take the medication, you check the blood sugar levels. So I also like the idea of doing this in these experiments. So that means I would have the PLC run
mm,
for a specific period of time, 3 minutes,
mhm,
and not have it be scanned, get the parameters, and then start the scan and still log the parameters. And then once the scan stops, I would continue to then log the parameters when there is no scanning. So what happens is you get these three bars. That means
mm.
in the database for a specific PLC, you will have a bunch of data points
Okay.
for 3 minutes
3 minutes.
that there was no interaction with any scanning tool. Then you will have a 1 minute period, so a bunch of data points, where there was an interaction
All
with
right.
a scanning tool. So there may be an effect, there may not be an effect. We don't
Mm,
know yet. And then even after the scanning is done, you want to see if there's any after effects. You one day you didn't take the pill, you checked your blood sugar. Next day you took the pill, you checked the blood sugar. And then the day after that, you don't take the pill, and now you see is like does the pill have some
wow.
residual effects
I see.
on the blood sugar the next day? That was like the idea or the thinking. And then the other thing that I hadn't seen other researchers do when it comes to this topic is to repeat the experiment multiple
Mm,
times. So, this is an important part
yeah.
to validate the repeatability of what is happening. So I
Mm,
repeated everything 3 times. Well, at least 3 times. Sometimes it needed more when something was failing.
all right.
Yeah.
So the 3 minutes and the 1 minute is based on also consulting others and getting information from other sources, right? Or it was your hunch or what?
Yeah, this one, well, to be honest, if you did 1 minute, 1 minute, 1 minute,
Mm,
it may have been just as fine.
hmm.
Um, the reason, the the thing is the middle part, the scan period,
Hmm. Yeah, it's the most
sometimes,
important one, I think.
yes, it's the most important. So this one was actually not fixed. So I said one
Mm,
minute, but it sometimes it was like few seconds, maybe less, like sometimes
oh,
even milliseconds of a scan, and sometimes a
mhm,
few minutes. So this
mhm.
part, it would vary. It was not fixed.
Well,
The pre and the post scan, you could do just 1 minute, but the
mm,
more data points you have, the more,
that,
let's say, a normalized baseline you can create.
mhm,
So yeah, that one, it was more of a hunch, again, based on the papers I
wow,
had seen. They were
nice,
shorter periods, but I wanted to take more data points to be sure
nice.
uh, that I'm taking account of any like major deviations or outliers, as
Yeah.
we say. So here, this is also an important part, Dr. Sulaiman, all the tools basically that I investigated. So there was two OT monitoring tools. Tool A,
Mm,
uh, I don't mention the names, and then Tool B. Those were used for targeted active scanning. They're like very popular vendor products.
all right.
Mm, Nmap targeted is basically Nmap, but there are specific
Mm,
scripts that have been
yep.
developed by great people who
Digital bond, I think. Yep.
uh, I'm not sure who I I,
I
I
think,
looked into the names of the ones who.
yeah, but it was hosted by Digital Bond by Dell, I think.
Hmm. That part
Yeah.
I'm not sure, but
Mm.
we can check with him.
Okay.
But yeah, so like Modbus Discover,
Mm.
etc., and yeah, Ethernet IP InfoScript. Yeah, these had been developed by individuals who were
Yeah.
essentially replicating what the vendor products are doing, but it's an open source capability.
I'm
Uh,
wondering why they stopped. I mean, they just made these scripts, 5 or 6, I think, and they
mhm.
haven't done for the other vendors. That's my observation.
Yeah, I believe it's based on individual efforts who,
Mm.
for some reason, had an applic like they had a use case of to
Yeah.
have this. Obviously, it's very interesting how they
Yeah.
develop. But yeah, that was for me to understand how open source tools are doing. And then here is the diagnostic tool that I mentioned. So using three separate diagnostic tools, and each one represents the uh, typical diagnostic tool or engineering workstation interaction. So the factory talk links is applicable to the Allen-Bradey PLC, the CodeSys for the Phoenix contact, and then using TIA Portal to simulate some interaction with the S7 PLC. So this one I classify as diagnostic tool activities. And then here, these three is back to that last point, which I highlighted in my gap slide, is looking at traditional active scanning.
Okay.
So using a vendor product that does IT scanning, and then using Nmap itself
Oh,
to do scans. And this one, for example, I didn't elaborate in S4.
okay.
Um, I was having conversations with some asset owners who were telling me that they would use IT scanners on their devices, even on some legacy PLCs, and they had
Yeah.
noticed what they had noticed when because you can configure the IT scanning as well,
Okay.
right? On how you do it, and like how it sends packets and in one format. And they had mentioned that when they are doing a TCP connect scan,
Okay.
which is, let's say, the modified method of scanning,
Mm.
they were getting positive results. They were seeing no practical impact on
Mm.
these legacy PLCs. But if they would do the same scan using its default out of the box configuration, which is typically seen as the SYN scan method, they would see an impact. So I wanted to
Mm.
understand why this like this, let's say, the TCP handshake connection, whether it's being done full or not, is it having an actual effect on the
Mm.
PLCs, and try to understand it. So that was the thinking behind the last two.
Okay.
Um, Sorry, did you have a question, Dr. Simon?
I was maybe later because you will discuss the results. I was gonna ask what are the possible impacts that could happen to a PLC
Mm,
from scanning.
mm, mm. So I think to get to that, I will skip a couple of slides, the ones related to statistical
It's up to you.
analysis.
It's okay.
Yeah, the one statistical analysis, we don't really need to go into it. The video is also there, so I will jump to the results themselves.
Okay.
So basically, what I saw in the experiments, and it can also be validated by talking to asset owners. I
Mm.
think the summary of it is that your as they say in North America, I don't know if I don't think it's an expression here. It's that like your mileage can vary. So what that means
Yeah,
is the result will vary depending on, well, depending on the PLC and depending on what the tool is doing.
of course.
So uh, what may happen in extreme cases is that the PLC can become unresponsive if it
Uh-huh.
is coming across a scan or traffic that it hasn't seen,
Mm.
and it's already has limited resources. It's a legacy
Mm.
PLC. Uh, it's a legacy PLC. It's already running multiple processes. There is no separate processor for the network communication and for the operational, let's say, processing itself. So in that extreme case, you can have that effect. Of course, I did not deal, let's say, with necessary legacy PLCs, so it's not an
Mm.
observation that I can say, but anecdotally, it is mentioned. Um, the
So
way
the
I
PLCs you dealt with are a bit newer, modern, right?
yes,
Yeah, all right.
they're more on the modern side. Yeah, like
Okay.
the S7 1200, not definitely
Mm.
uh, not as recent, but it's still like not the oldest possible model that I could have tested.
Mm.
Um, Overall, some PLCs probably because of the processing capabilities, the way that they are built, whether they have a separate processor or even more resources, will will most likely be resilient to the type of scanning, whether it's a OT scan, as we can see here for the compact logics, or even for the IT scan. But
Mm.
then there are other PLCs that may not be as resilient. There will be an effect in terms of the locked parameters.
Mm.
So the reason the locked parameters are important is because the scan time is going to be indicative
Mm.
of the speed of the processing speed of the PLC. Longer duration, that means the PLC is struggling a bit. Regardless, based on these numbers, even with 55%, etc., there was no shutdown. So this is what I was referring to. But
Mm.
also there's a limitation in my study. The limitation is that the PLC was not a dependency for other devices.
Mm.
So if we want to take this research to a next step, we would want to connect a device
All right.
to the PLC
Mm.
and then see if the delay in the scan time is causing a delay in the device or the process
Mm.
that is controlled by the PLC.
Oh, I see. I see.
You see what I
Mm.
mean? If there is
Mm.
a 200% jump in the scan time, if there is a big delay
Mm.
in the PLC's scanning due to active scanning, due to targeted active
Mm.
scanning, will this have a practical or implication on the operational process of the PLC? And the best way to do that is to create a more elaborate process using the controller.
So what you're saying is the PLC will affect the sensor, for example, right?
It could
Or
potentially,
a, or
it
a,
could,
or a pump
it
or
could,
whatever. Yeah. Okay.
it could potentially,
Yeah.
yes,
Okay.
it could. But in this case, what was interesting, let's say with the PLC Next, I saw a small jump in the scan time. You'll see here, the
Mm.
mean scan time. So that means, you know how I told you there was that middle bar, which is the data points during the scan period,
Mm.
and it was not fixed. It changed depending on the tool itself, like how long it takes the tool to scan.
Mm.
So when you take the average of those data points, uh, it
Right.
turned out that there was an increase in just 5.7%
Mhm.
when I used Nmap targeted. But for anything else, statistically speaking, the curves, let's say the distribution curve, as we refer to it, for the scan time,
Mhm.
uh, I don't have the curves here, but the distribution curves are
Right.
there's minimal to no shift between pre-scan, scan, and post-scan. So that means in a real world, from a real world perspective, there's no effect on the PLC. So this
Right.
is for the PLC Mac. But for the S7-1200, when we used OT monitoring tool A, we saw a big jump.
Yeah,
55%
very
is
big.
significant. This is what the box plot looks like. So the dots that you're seeing,
Yeah.
my cursor, the dots that you're seeing is basically every individual data point.
Mm.
Every individual data point for the scan time that's logged during the test. Now, in the pre-scan and the post-scan, you'll see that
Mm.
the majority of the data,
Yeah.
and this is the nature by boxplot, is here. So it's around 1,200, let's
Mm.
say, or yeah, let's say something around that. The majority of data. There's some data points like which we refer to as outliers that are outside of that,
Mhm.
but maybe like 5%, 2, 3% of the data.
Mm.
The data points during this period is in this range. But then during the scan, so when the tool is actively scanning the PLC,
Mm.
almost the entire distribution
Mm.
has jumped.
Yeah.
So it's no longer an outlier. That means every data point, almost every data point that you're logging
Mm.
is in the 2000 range, which is, it is significant statistically. But again, I don't want to to scare and say
Mm.
like this for sure is X, Y, and Z on the process, because no, I don't know. I did not have an XYZ process to tell you what the exact impact would be, but it is a word of caution, and that is how I thought about this study and what I
Mm.
talked about in S4. It's a word of caution that there is a responsibility of the vendors to do
Mm.
these testings, because
Yeah.
they're, after all, developing these profiles, and they are developing these targeted active scans on specific devices. So just do those tests and see what are the results, and maybe you have the resources to do a more elaborate understanding of the interaction between the controller and external processes like sensors, etc., and then publish those results. But and also the same responsibility lies on the asset owners and even service
Mm.
providers to to do these tests.
Mhm.
Yeah, because it's critical, but also there should be some sort of a, let's say, um, a guideline for
Yeah.
organizations to classify. Yeah, I mean,
Yeah.
they probably already have. Here's the critical PLCs. Here are the legacy PLCs. Here are the ones that we're okay to have just passive detection. Here are the ones that we actually need to get more or enriched
Mm.
information. And there needs to be a plan around those PLCs. So will you scan them or will you not scan them? If you don't scan them, are you okay with the limited asset information? Are there other, let's say, compensating methods to get that information, whether it's configuration files, etc.? And then if you are going to scan them, what are the risks associated to them? Because there can be dependencies on that PLC. And is there some sort of a schedule that you want to follow? Like maybe
All
you
right.
only do during the downtime window, or maybe, those kind of scenarios.
Maybe we should raise a question for the guests to guess which tool A is causing this issue. Also, it would be handy, like you said, if there is a website for the
Uh,
OT community to check which PLC or the PLC results that you showed for
mm-mm.
various vendors, so they can choose what to buy and what to choose based on their. That would be really handy.
Yeah, of course, of
Yeah.
course. Um,
We should guess which tool A is.
it's not very hard. It's really
Okay.
not very hard to guess because of my talk. I mentioned
Yeah.
their categorization, so it
Tool B,
really,
huh? Okay.
yeah. So, this is for tool B, and this was the
Yeah.
benefit of doing the Wireshark capture and analysis, because I could see like what was happening. So typically, as I mentioned, with target active scanning, it's simulating the interaction of a protocol with a PLC. So here, and not just for this tool, tool A, tool B, and even for the Nmap targeted,
S7, huh?
it was simulating the S7-COM interaction with the S7-1200 PLC.
Mm.
Um, I don't know if we have to go. If we want to go into the detail, but
Yeah.
essentially what I'm highlighting here is that the the step-by-step process for tool B was being followed successfully.
Uh,
Uh, so basically what happens is with the S7, there's the SZL read request. It's German, stands for System Status List. So there are
okay.
certain parameters that the diagnostic tool or engineering workstation software or in HMI based on the manual is pulling these
Mm.
parameters. So this is what tool B was simulating.
Mm.
Some of them were successful and some of them were not. Like this one, for
Mm.
example, here that I'm showing with my cursor, the second purple packet, that one was not successful. An error code was returned
Error.
by
Yeah.
the PLC. But the tool B just continued. It continued sending its parameters.
Mm.
So then it sent another request to read another parameter. I don't know I mean, I don't know by heart what these parameters are.
Uh,
But then the response was fine, and this was the
mhm.
let's say the scan for tool B. And then, yeah, this is just the same information. And then this is for tool A. So this is important to know. Tool
Uh,
A
yeah.
is the one that had the increase, right, by 50%.
Can
So
we identify it here? Yeah.
what do you mean?
I mean the issue, the delay. Can we like if we read this packet, can you tell what went wrong?
Sure. So basically what
Yeah.
happened is the tool A
Yeah.
sent a packet to read this specific parameter.
Okay.
And even before that, there were some retransmissions that were happening,
Mhm.
which I was unable to actually understand the answer. And I also
Mm.
leaned on some experts that
Mm.
work with this PLC or even like work with this vendor a lot. But even despite that, basically what happened is an error response was sent by the PLC. So very similar to the previous case, which I
Mm.
showed.
Mhm.
Sometimes it's possible that the PLC will not recognize that
Okay.
parameter. So especially with the S7-1200 regarding the S7-COM communication.
Mhm.
But when that happened, instead of tool A jumping to the next read request, which we saw tool B do, right? It moved
Mm.
on to another read request. It basically was sending the same packet again. It was trying to retransmit it.
Mm.
And then eventually, I suspect that uh, may have overwhelmed
Oh, I
the
see.
the PLC. So it decided to basically to reset the connection or to try to drop the connection, but it was a reset.
Uh,
And then this interaction that you're seeing here, so the part that I'm showing with my cursor, it actually happened
mm.
3 times in total. So this happened, then it happened again with the exact same
Oh.
parameter, with this parameter, 0D91.
Mhm.
And then after the third one, OT monitoring tool A jumped to a new parameter. So the same way we saw tool B move on to a new parameter after the first
Mm.
one, it took tool A 3 times, three
Mm.
failures before it does that.
Okay.
Why it did that, I don't know.
Mm.
Yeah, I don't know how exactly they design these
Mm.
tools. I'm sure there is a way to specify what the how the tool is going to respond when it receives an error code. Maybe
There,
with this tool,
there's
with
no
error.
debug mode or something for the
I
PLC.
don't believe that's accessible to the normal user. It's
All
more on
right.
the for the product team of that vendor
Okay.
to investigate to find out.
All right.
Um, but it was, yeah, certainly very insightful to see this.
Hmm.
Um, so yeah, that was pretty much it. There
Interesting.
were other experiments, of course, with other results. We didn't get to go through them. But I'll also mention, like, sometimes it's hard to differentiate, what is it that's causing the impact?
Hmm.
Because for the compact logics, for example, the Ethernet IP, um,
Hmm.
the Ethernet IP interaction, or like the grabbing the info through that interaction, is
Okay.
not a is not a very long or elaborate um, communication structure or protocol. It's
Hmm.
very short, it's few milliseconds.
Hmm.
So for that one, even if the monitoring tool A, B, or whatever it was, if it was doing something improperly, maybe it would never affect the PLC. So maybe it's a function of the protocol itself, not just the PLC and the
Hmm.
PLC resources. But for the S7-1200, because it's the I there's actually a funny, when I was trying to learn about the S7 protocol, I can't show the picture now,
Yeah.
but the guide that talked about it showed, and maybe your audience has seen it, and it's easy to find, but there's like a very old car, like, I don't know, from the 60s, and
Hmm.
then it's loaded with a bunch of
I think I
cardboards,
know. I saw this guy. I think
yeah, cardboards, couches, anything that you want, TV, and they're saying that this
he is
is what,
legacy too.
yeah, this is what the
Yeah.
protocol is like. So I think, yeah, it's a complex thing. There's the PLC resources, there's how the tool is interacting, how it's
Hmm.
responding to errors, but also the protocol itself. Is it is it susceptible to cause an impact when something goes wrong?
Hmm.
But at the end of the day, the my conclusions from 6 months ago, from a year ago, is the same. Scanning is important if you can
Hmm.
do it, if the OEMs approve of it, if
Hmm.
the business allows it, or I mean, typically the business wants
Yeah.
the visibility, they're less likely to object to it, but the operations may not want it.
Hmm.
But it's important to be cautious and to have a structured way so you can have an answer at the end of the day, instead of saying, yeah, like, there's no risk, or there's 1 out of 10, but what does this 1 out of 10 really mean? So yeah.
Yeah. Interesting. Thank you for explaining your research. I heard that you will publish this, right?
Yes, I do want to publish this in
Yeah,
a
please.
in a journal.
It's a good idea. Yeah.
Unfortunately, as you know, I've recently moved to Emirat. I'm in Abu Dhabi.
Uh,
So, not unfortunately, I'm very happy, but it takes a bit of time
yeah, I
uh,
understand.
to find the flow, and then so I've been
Please,
busy with it.
please let us know when it's published so
Yes, for
we
sure.
can we can look at the results and learn from it.
Yeah, for
Also,
sure.
I mean, you mentioned many challenges, many for the security people when they do
Mm,
this kind of research that they don't understand what these devices are doing, for example, and
mm.
also the protocols. Those, in-depth information. How do you look at it? Do you think how could the security people learn this stuff? Is it possible? Do they have to change it? Do they have to standardize the protocols in order, like the IT,
Mm.
so the language will be understood by both sides? So what do you think?
I think that's a good question. I'm
Mm,
sure I am aware through conferences, etc., and
mm,
white papers that there are efforts to do these standardization of protocols, etc.
mm,
But from my perspective, even though I think about things from a
mm,
technology or technical perspective, if I look at this research and
mm,
how I conducted it,
mm,
and the reason why it was helpful or brought insight to the community, the secret to it was
mm.
interacting and leveraging people who are experts
Yeah.
in the day-to-day operations of these devices. Because, so what I'm trying to say, instead of going through that standardization,
Mm.
process, which is going to be nearly impossible with all the protocols, all the devices,
Exactly.
all the existing ecosystem. I think it's more from the human side where it requires the interaction of IT, security with
Mm.
OT
Mhm.
to understand the processes and then to come up with methods that address any risks or help quantify risks
Mm.
if a security control can potentially pose as a risk, or if it does not address external or internal cyber risk. So that's how I view it. And a lot of, as I'm mentioning, a lot of my research
Mm.
is based on those interactions and the help of people who know way more about me in terms of these devices and how they should be operating.
Nice.
Yeah.
Do you think AI, if there is a AI project like
Mhm.
maybe like ChatGPT, that
Mhm.
if it was fed with information about these technical expertise, then maybe you just if you don't understand, for example, a packet, then you just copy it and ask the tool to translate it for you. Do you think this is possible?
It's funny you mentioned that because I
So
was trying to
it's
leverage.
database.
Yeah, it's
Yeah.
funny. Yeah, it's funny you mentioned that because I was at one point trying to leverage Chat GPT
Yeah.
to understand some things about the protocols, etc., the packets that I was seeing, but it was very useless. It was better to when asking an expert. In terms of
Mm,
how I see it being used for this kind of research, uh, I'm not sure. I mean, it's hard to say.
mm,
It's hard to say. I mean, if you what will end up happening, well, with any type of modeling, whether it's through AI or not,
mm,
you have to collect actual data points. So these types of experiments have to be repeated
mm,
with so many variations of PLCs, of protocols, of tools. They have to be repeated to collect the actual data
mm,
about parameters, about the effect on the PLCs. Only then, once you have that elaborate database, you can think about, okay, can I apply some sort of machine learning or multivariate analysis, as they say, to understand what it is that is affecting the PLCs. But until we get there, I don't think I can't see ChatGPT or anything, at least for my personal use, to be helpful here.
we will see.
Yeah.
Okay. So let's talk about the OT security community.
Mhm,
You've spent most of your time in Canada doing this kind of stuff, right?
mhm, mhm,
And then now you've moved to the Middle East. What differences do you see about the community there and community here, or
mhm,
the kind of challenges they face in Canada
mhm.
and the challenges they face here in the Gulf area or United Arab Emirates?
Yeah.
What's your experience so far?
Well, I think I can tell you organizations here OT organizations are very, very mature. Um,
Mhm.
initially, I hadn't interacted with the ecosystem here, so
Mm,
it was hard for me to know. But in comparison with North America, with Canada,
mm,
uh, yeah, they're very mature. Also, what I've noticed is here there's a trend to adopt the latest and greatest in security,
mm,
which is good, which is good. But there can also be downsides associated to that
mm,
because you can be quick to adopt, but then it
mm.
can have operational impacts, right? It can
Yes.
have an effect on the processes of how you do things outside of just cybersecurity. That part, for example, I wouldn't see as much in Canada. But again, it depends on how you look at it, whether it's positive or mixed.
Mm,
Um, but yeah, high maturity, high adoption of new security capabilities,
mm,
um, typically very complex ecosystems in terms of the the OEMs, the automation vendors. They have strong presence when it comes to cyber monitoring or OT visibility. Over the years, the automation vendors have also developed their own capabilities. So
yes.
there's a lot of competition, not just between
Mm,
uh, the typical vendors or the typical, let's say, uh, yeah, the typical candidates, but also others. So yeah, highly competitive market, and a lot of very good engineers from all over the world uh, come here as a
wow.
melting pot, I would say, from India, Southeast Asia,
Yeah.
from uh, Northern Africa, Europe, North America, like everywhere. So yeah, overall, very interesting.
So,
So
in terms of the talents that who are coming to your area, I mean UAE, are they knowledgeable in OT, in just OT, or do they have the cybersecurity skills as well? Have you noticed any gaps?
I've seen a mix. I've seen a
Mm,
mix. Some have been from just cybersecurity, perhaps IT, who transitioned to OT,
mm,
although those are very few. Um, there are many who uh, they come from OT backgrounds and then transition to cybersecurity,
mm,
and those are typically I see as the most solid, the most yeah solid talent because they already know and think in the OT way.
yeah.
Versus if you come from the
Yeah.
IT or cybersecurity, I mean, of course, it's not a rule, but
But
it takes a bit longer to understand
yeah.
how OT thinks to mold that.
Mm,
But OT is already thinking about security all the
mm,
time, so it's just
yeah.
from the physical operational security to more digital security, so the adoption becomes easier.
Nice.
So yeah, it's a mix.
So you are a chemical engineer, right?
Yes.
So
That's
you studied mostly, I think, chemical uh, concept, chemical processes, chemical
Mhm.
whatever chemical. So like for example, pharmaceutical, right?
I was more focused actually on water,
Ah, water.
like water
Okay.
treatment, water and wastewater treatment. I did both my bachelor's and master's in chemical engineering,
Mm,
and I most of the work I had done through university and the courses that I took was oriented to research. So I really like thinking about research subjects and
all right.
investigations, and that's how it connects to this as well.
Me too. I connect with you on the research path. That's what I did. I'm still doing.
Uh,
So, I mean, how you transitioned or how you gained your cybersecurity knowledge as a chemical engineer? Is it by experience or did you take any courses or?
I think I was fortunate. I
Mm,
was lucky because when I, graduated and was transitioning into a career,
mm,
I I knew I did enjoy chemical engineering, but I
mm.
was always more on the computer side, and
Ah,
it was a passion, but
okay.
I couldn't pursue it for specific reasons. That's why the first step of my career was in cybersecurity, and I
Hmm.
was lucky because that's was a bit of a like that jump in the 2018 2019 period, let's say in terms of OT security, at least in Canada.
Hmm.
I was fortunate because in the previous company I was working, there was an initiative to build a lab,
Hmm.
uh, an OT cyber lab,
Nice.
and I leveraged that opportunity
Cool.
to learn the fundamentals of, well, a lot of things that are important for cybersecurity,
Right.
networking, of course, being one of them. Um,
Hmm.
in terms of courses over the years, I did take, maybe a, a couple of
Hmm.
courses every year or so on specific
Nice.
things.
Nice.
But I would say the bulk of it has been through learning, through getting hands-on experience,
Hmm.
asking questions, asking other people, and just following the things that make me curious, such as this topic.
Nice. So, what do you say to people who come from, I mean, the engineers, the OT engineers? Should they learn cybersecurity during, after? What do you?
Well,
I,
I think, yeah, based on what I see, the
mm,
ones that have been more successful, although it's hard on how you define successful. It could be
mm,
successful because you transition faster or easier, or because you were able to gain more knowledge.
mm,
You have to gain the cybersecurity during uh, during the most, because you have the opportunity
mm,
to learn things from other security folks. You can also leverage
mm,
courses and
of course.
courses, classes, etc., and then try to see how they apply on your actual systems and day to day. And it will be easier to learn and have an association with what you're learning. You can still do it after, but then you will have to, I mean, it depends on how you learn, but you will then have to revisit things that you had done
Mm,
to understand how it applies to what you did before. So my recommendation would be to do it during.
okay. My my last question. How can somebody build a lab for himself? What steps, what direction, what resources do you recommend for
Mhm.
somebody with a limited budget, say, for example?
Mhm, mhm, mhm.
Mm.
Yeah, that's a great question.
Because you're
So,
a researcher and you've built a labs, and so maybe we
mhm,
should learn from you.
yeah. So I would say it's important to first identify what you want to achieve with the lab,
Mm.
like what are your objectives. And once you determine that, you can identify what are
Let's
the
say, for
main.
example, I was asked, I want to build a malware. Once somebody asked
Mm,
me a malware on
mm,
OT
mm.
network. So can we go from there, please?
Uh, yeah, so let me think. For that kind of environment, you still have to think about what are your objectives.
I see.
You still have to think about your objectives. You have to come up with a design It could
Mm.
be minimal design needed in
Mm.
terms of meeting those objectives. So what are you trying to achieve with the malware, for example? Is it you just want to have a malware that interacts
With a PLC.
with PLC? Okay,
Yeah.
then we'll have to identify those components that you want to have, and
Mm.
you can leverage on there's so many online resources
Mm.
on products, or even on whether it's physical or virtual products that can help you set up that lab.
Mm.
And then for, let's say, generating the actual malware, again, like uh, it's a lot about online research, finding sources. And this is interesting because it's a topic that I've been recently looking into. There's so many databases, for example, where you can actually get malware samples that actually have the signatures of malware, but they're not active per se. And it
Mm.
depends, it goes back to what your objectives are, what you're trying to test. Maybe you're testing endpoint protection, or maybe
Mm.
you're trying to test how to lock that specific workstation, or maybe have something impacted on the PLC. So you basically leverage online resources, and then also don't be afraid to reach out to experts in the community who you see are specializing in this, to schedule a conversation with them and to understand how you can enrich the information you already have to build that lab or that capability.
Nice.
But if there's a will, then there's definitely a way.
Sure, of course. So thank you, Raf. Shall I say Raf or Raphael?
Well, the way you like,
Uh,
Raf is usually for
yeah.
close friends. So now I consider you a close friend, Dr.
Yes,
Sulaiman.
it's my pleasure to have you as a friend. And thank you for joining ICS Arabia. Now we finally can close the question to scan or not to scan, hopefully. If there is any more question regarding this question, please send me a comment or send Raf a comment in LinkedIn. He's available on LinkedIn. So thank you, my guests. Thank you, Raf. It's been a pleasure. Thank you for your research and contribution.
Thank you, Dr. Sulaiman, for having me, and
It's my
amazing
pleasure.
job with the community that you have built. It's
It's
great
my
for the region.
thank you very much. It's my pleasure. Okay then. Take care all. Bye bye.